Hello, good morning, everyone. Uh, most of the topics from the unit second, it is state variable approach, is completed. Some of our little topics are left, so let's complete these topics. So, first of all, we'll learn how to draw a block diagram from a state model. How to draw block diagram from a state model or from differential equation or from transfer function. So let's take a transfer function like ys over us, which is equal to 1 over s cube plus 9s square plus 26s plus 24. And now I want to draw block diagram of this transfer function. So for this purpose, first we cross multiply this equation and I will take inverse Laplace of this equation. Then we get y triple dot t plus 9y double dot t plus 26y dot t plus 24 yt is equal to ut, right? Or y triple dot t is equal to minus 9y double dot t minus 26 y dot t minus 24 yt plus, right? And now if I take an integrator like this and consider here I have y dot, then obviously here I'll have y. So considering this concept, I'll draw my block diagram from this equation. So I have 1, 2, 3 derivatives. So I'll take 3 integrators. First integrator, second integrator, and then third integrator. And here I will get r yt. So here we will have y dot t. Here we will have y double dot t, and obviously here we will have y triple dot t. And from the equation I have y triple dot t is equal to minus 9 y double dot t. So multiply here minus 9 and add it here. Right? Minus 26 y dot t, here I'll take minus 26 and again add it here. And again minus 24 yt minus 24 yt, and this will add up here. And plus ut. So add ut here as an input. So this is our block diagram from this transfer function. And now if I want to draw state variable diagram, state diagram, then nothing I have to do, just take Laplace of this diagram and remove this block from an arrow and a transmittance of that arrow, right? So after taking Laplace, I'll get here S inverse. Here also I'll get S inverse, and here also I will get S inverse. So let's consider here I am having 1. So here I am having S, here I am having S square, and here I am having S cube, right? From S square, an arrow is going here with transmittance of -9. From S, an arrow is going here with transmittance of -26, and from 1, an arrow is going again here with transmittance -24. Here I have US, and here I have YS, and this is all about state variable diagram or state diagram. So this is necessary to proceed further on the next topic. So next topic is decomposition of transfer function. Decomposition of transfer function. So first is direct decomposition. Direct decomposition, and direct decomposition to controllable canonical form or observable canonical form. So first, direct decomposition to controllable canonical form, direct decomposition of transfer function to controllable canonical form. कंट्रोलेबल कैनोनिकल फॉर्म में हमने क्या देखा था कि सिस्टम इनपुट से कंट्रोल हो रहा है या नहीं, मीन्स मेन रोल is of input in controllable canonical form. So let's take an example, and an example is CS over RS is equal to S plus 6 divided by S square plus 5S plus 6. For direct decomposition to controllable canonical form or any form, I'll divide this equation with S power 2, means I will first convert it into S inverse. So here I get S inverse plus 6S minus 2 plus 1 plus 5S inverse plus 6S minus 2. And let's consider a dummy variable QS such that CS over RS becomes S inverse plus 6s minus 2 divided by 1 plus 5s inverse plus 6s minus 2 multiplied by qs divided by qs. And in this case, I can write Cs as S inverse plus 6s minus 2 multiplied by Qs, and Rs I can write it as 1 plus 5s inverse plus 6s minus 2 Qs. Right? So I have two equations, one is here and second is here. First take this equation and rewrite it as Qs is equal to Rs minus 5s inverse plus 6s minus 2 Qs. Right? And now if I draw state diagram of this equation, if I draw state diagram of this equation, SVD, state variable diagram of equation 2, then I get, here I have Rs input, right, and let's say here I have Qs, the state, intermediate state, and since I am using S inverse and S power minus 2, so here I have S inverse and here I have S inverse again. So here I am getting S power minus 2 and here I am getting S inverse. From here I am multiplying minus 5 and adding it here, and from here I am multiplying minus 6 and adding it up here, right? So this is our state diagram, state variable diagram for this equation. Similarly, state variable diagram for equation 1, SVD of equation 1, Qs is here and here I have S inverse, here again I have S inverse, and S inverse plus 6s power minus 2 will be our Cs. So here I am getting S power minus 2, so multiply this with 6 and this S inverse will come here like this, and then I am getting here Cs. And on combining these two graphs, I am having here I am having S inverse, here I am having S minus 2, here I am having Qs, and here I am having Rs. From here a transmittance is minus 5, from here a transmittance is minus 6, from here a transmittance of 6, and from here a transmittance of 1 is here, and then I am getting Cs. This is my state diagram, and from this state diagram I am having equations like here I am having x1. If here x1, then here I am having x2, and here I am having x2 dot. So x2 is equal to x1 dot. This is S inverse, right? So x1 dot is equal to x2, and x2 dot is equal to RT minus 5x2 minus 6x1, and CS is equal to, CT is equal to x2 plus 6x1. This is our state equation and output equation, and in matrix form I can write it as x1 dot x2 dot is equal to 0 1 minus 6 minus 5 x1 x2 plus 0 1 RT, and CT is equal to 6 1 x1 x2. So I am having three matrices A, B, and C, and this is our controllable canonical form. Controllable canonical form. Now, direct decomposition to observable canonical form. To observable canonical form, right? Let's take same example. CS over RS is equal to S plus 6 divided by S square plus 5S plus 6. Now again, this can be written as CS over RS is equal to S inverse plus 6S minus 2 divided by 1 plus 5S inverse plus 6S minus 2, or this can be written as CS 1 plus 5S inverse plus 6S minus 2 is equal to RS S inverse plus 6S minus 2, or CS is equal to RS S inverse plus 6S minus 2 minus CS 5S inverse plus 6S minus 2, right? And now I am drawing its state variable diagram. So state variable diagram will be like, here one is for S1 S inverse. I have two S inverses, so here I have one S inverse, one node here, one node here, and again here I have one more S inverse, one node also here. Here I am having CS, and here I am having RS. At this point I am getting S inverse, and this point I am getting S power minus 2. So CS is equal to minus 5 S inverse. CS is equal to minus 5 S inverse. So from here loop -5 with transmittance and -6 s power -2, and RS, from RS I am having 1 S inverse and 6 s power -2, and this is our state variable diagram. And from this state variable diagram, if I am having x1 here, then here I am getting x2, which is equal to x1 dot, and here I am getting x2 dot. So equation becomes x1 dot is equal to x2 and x2 dot is equal to x1 dot is equal to x2 plus RT minus 5x1, right? And x2 dot will be equal to 6RT minus 6x, right? And what about CT? CT will be x1. CT will be x1, right? So in matrix form, x1 dot x2 dot is equal to here -5 1 -6 0 and x1 x2 plus 1 6 RT, and CT is equal to 1 0 x1 x2. This is our observable canonical form में decomposition, direct decomposition to observable canonical form, right? Direct decomposition to observable canonical form, right? So in this way I can convert or decompose my transfer function into controllable canonical form and observable canonical form. Now, next is cascade decomposition. Cascade decomposition. So let's take an example. Ys divided by us is equal to, I have s plus 6 divided by s plus 3 and s plus 2, right? First I am taking g1s as s plus 6 by s plus 3 and g2s as 1 over s plus 2 for cascade decomposition. And let's draw state variable diagram for g1. which is ys over us is equal to 1 plus 6 s inverse divided by 1 plus 3 s inverse qs over qs, and from here I am getting ys is equal to 1 plus 6 s inverse qs and us is equal to 1 plus 3 s inverse qs, or qs is equal to us minus 3s inverse qs, and this can be drawn like here I am having us one, here I am having s inverse. From this point minus 3 and this is qs, and 1 plus 6s inverse qs is ys. So ys will be from here I am getting 6, this will be like this. Here I am having ys, right? So this is state variable diagram for G1, and that for G2 I can draw it as here US transmittance 1, here I am having QS, this one is S inverse, this will be 1 plus 2S inverse, right? S inverse over 1 plus 2S inverse. So from here a feedback of minus 2